Welcome AP Chapter 5. We got thermochemistry. This is actually part 1 chapter. Part 2 is chapter 19. But we talk about energy fairly a lot in AP Chem. But let's get down into the deep part of energy. So we call it thermodynamics. Thermodynamics is the study of energy and how it changes, how it transforms. The Greeks they have their meaning called heat and power, which is thermodynamics. But why is this chapter called thermochemistry? Well, because in chemistry, we look at balance equations on how chemical reactions change, but how that change involves heat and energy. We all have done labs. We've all seen chemical reactions. We've seen heat, bubbles, smoke. Sometimes it even gets colder and forms ice. So how does that chemical reaction change when it involves heat and energy? Well, we got some definitions to cover. First of all, what the heck does energy mean? It's the capacity to do work or transfer heat. So when we talk about energy, especially the next video coming, 5.2, the law of conservation, energy cannot be created or destroyed, but what we do is we rearrange it in work and heat. You're going to find out in this next video that work is a little w and heat is a little q. So that's the symbols that we're going to use for work and heat. The definition of work is the energy used to make an object with some type of mass move. Like the example of the bike example coming down below, you moving your pencil, you blinking your eyes, you are doing work. Your brain is functioning, hopefully listening and not on your cell phone at the same time. Heat is the energy used to make the temperature of an object increase, but it could also decrease too. So when we produce heat, obviously temperature is increasing, but when we produce coldness, obviously the temperature would be decreasing, okay? Sorry for my dogs and their dangling tags around their necks. So with energy, we're going to start with two types of energy. We got kinetic energy, which kinetic energy is the energy of motion. You moving your pencil, you highlighting, like I said, you blinking and moving your eyes. The more you move, the more kinetic energy that you gain. But what's the difference with potential? Potential is a little difficult. We actually looked at it in chapter 14 when we were looking at activation curves, activation graphs, okay, which you'll see it in this video too. Potential energy is the energy that an object possesses at a certain position in time. Okay, it has nothing to do with at rest. It has nothing to do with not moving motion. Okay, it has to do with if you were going to tell me the energy that you have at that position in time, that's what's called potential energy. Doesn't mean that you're moving. It could be an egg sitting on the counter. It could be this girl right here sitting on the hill on a bike. That is potential energy. But what we can do is we can always change that potential energy and we can convert it into kinetic. But we can go both ways. So potential energy, I can convert it to kinetic. Now I got motion of moving motion. But I can also convert it back into position of energy. So I want to give you an example of a bike. So say the girl is on her bike. She's at the top of the hill. Okay, she's at the top of the hill. So at, I guess, time zero, if you'd like to say time zero, she is just at the top. She is getting ready to start. She has a lot of potential energy. She is not moving. She is getting ready to start the race. As soon as she starts, she is going to start to take that potential energy and going to start converting it into kinetic energy. And why is that? Because she's got to move the pedals. She's got to make the wheels turn. And when she does that, then she's changing that energy of position into kinetic. Now, whatever energy you start with, you have to end with that same energy in the end. So the starting and the ending have to be the same. So these two, no matter what, have to be the same. It's a law in chemistry. It's called the law of conservation of energy. You didn't create or destroy it. You rearranged the energy. But in the end, your total energy, when you add up your potential and you add up your kinetic, that total energy is the energy that you started with. So we call that total energy. Over here, same thing, total energy. So if she started with like 100 joules of energy, then in the end, she's got to have 100 joules in energy. But how it converts, so you're going to start to lose some potential and you're going to start to gain some kinetic. In the beginning, all you had was potential and you had no kinetic. Now, as she goes down the hill, she's going to be gaining some speed. Okay? And what's going to happen is you're going to lose even more potential energy. Lose more. And it's going to gain more because she's going fast. Okay? Think of a car. Every time you put your foot on the gas pedal, you're making that energy work harder, that engine work harder. And now you not only are changing your position because you're moving, you're also gaining energy because you are moving. So you're changing position and you're changing your motion. Now eventually she's going to flatline into that stop sign. I think it's a hexagon. Stop signs. That's really bad. Okay. So as she slows down, now that kinetic energy that she gained is now going to start to go back to potential. So by the time she gets to that stop sign, all the potential is all she has. So once she gets to the stop sign, potential energy, she's done, she's resting. But now she's got no more kinetic. Okay? So that's how energy gets conserved and how energy gets converted from one to another. Now, what's the units that we use for kinetic energy? We use something called joules. Okay? Joules is the SI unit for energy. Now, you know AP likes to use the kilojoules. So that means little King Henry could come our way too. But joules is the SI unit that we use to communicate from one place to another. Okay. Now, kinetic energy has an equation. Now, whether you want to call it EK, I always call it K capital E. Okay. It's 1/2 mv squared. Now, the m is mass. But here's the part that students always mess up this equation. You're so used to mass being grams, but it doesn't correlate to that when it comes to this equation. You need your mass to be in kilograms, okay? So you got to take those grams and you got to convert it, use your King Henry and get to kilograms. And I'll show you why. V is velocity, okay? Which some call it speed. In physics, they like to call it velocity. In chemistry, we call it velocity or speed. Either one, that's how fast you're going. We need meters per second. Okay? So down here at the bottom, if you're given miles, then you got to change those miles into something else. If you're given hours, you got to convert it into seconds. Okay? So the reason why we need these specific units is because when we take 1/2, we put our mass number in for kilograms. We take our velocity and we take meters over seconds, but we're going to square this. That square goes for what's inside this parentheses. So what you have is 1/2 kilograms times meters squared over second squared. And all of that unit equals a joule. Okay? So that's why we have to have specific units for the mass and velocity, because that's what a joule breaks down into. Okay? Now, you know, as you go faster, you're gaining energy, but not only gaining energy, you're gaining kinetic energy. So let's bust out this calculator and let's try a sample question. We have a bowler, okay? And because I got a lot of athletes in the class, let's say this bowler right here. Oh, we'll go with Brandon. Okay. Brandon is bowling, and he's bowling with his friends, Brian and Giancarlo. Okay. And Brian, he lifts a 5.4 kilogram bowling ball from the ground to a height of 1.8. So the bowling ball, and I'll just put it BB. Hey, BB, bowling ball, Brandon, he knows what that means. Okay. That bowling ball, he is now lifting it to a different position, to a different height. Okay. As he raises it up, what happens to the potential energy? Is he moving the ball? No, the ball's not moving. The ball's being lifted from one position to another. So what happens to the potential energy? The potential energy increases because he is changing the position from a lower position to higher. Okay. Your potential is increasing. You can also mention how he's working, because remember, what was the definition of work? Work is the energy used to make an object with mass move. He is working against an actual force. He's working against gravity. And because he's working against gravity, that position is changing because he is working against it. So your kinetic isn't changing. Your potential energy is increasing because he's going from a higher location to a lower location to a higher. So now if we calculate the energy, okay, the ball then drops and gains kinetic energy, 85 joules. So I'm going to write down some information that we know. He then takes the ball that he was holding, gives it to Brian, and now Brian has the ball, and now he's going to drop it. Well, as he drops it, it's gaining kinetic energy, okay, because you dropped the ball, and it's going faster and faster until it hits the ball. So he is gaining kinetic energy, okay. I do know the mass of the ball. The mass of the ball is 5.4 kilograms. So I got my mass. I want to know the ball's speed. I want to know the velocity, okay? So with my know and my don't know, I'm solving for velocity, okay? So always write an equation. Kinetic energy, 1/2 mv squared, okay? Usually when we start these problems off, I would start you off by solving for kinetic energy, but we're advanced, we're AP, okay? We can solve for this. I not only want to solve for velocity, but I'm going to have to figure out how to get rid of that square too. So I have the kinetic energy and the units that I want, 85 joules, okay? I have 1/2, but that mass needs to be in kilograms, which I have, 5.4 kilograms, okay? And then I'm going to solve for velocity and then squared. This square only applies to the velocity. So let's get our equation, our calculator going so we can plug these numbers into the equation. So first, let's take care of this part, okay? And I'm just making notes in red. You don't have to do that. So 0.4 basically times 1/2, or you could say divide by 2, okay? So right here, I have 2.7, but I still got kilograms, okay? And then, how do I get this number to the other side? Well, I'm going to divide each side by that 2.7 kilograms, okay? Now, remember what a joule breaks down into. 85 joules is kilograms times m squared over second squared, okay? Let me move that over since it's in the way of that equal sign. So m squared over second squared, okay? So when I divide by kilograms, I divide by each side, okay? This is gone. So now I'm just going to have my velocity squared, okay? But then I take these kilograms and divide by that kilogram. So now I'm just going to be left with m squared and s squared. So let's take that 85 divided by 2.7. So 2 sig figs. Don't have to worry about rounding yet if you don't want to. Looks like the calculator says 31. So 31 m squared over second squared. Now I need velocity. Okay, so to get rid of a square, you take what's called the opposite. So if you look on your calculator, you have a square button. Right above it is something called square root. So to get rid of the square, you have to square root, but here's the kicker, both sides. Okay, you know I will always teach you the math. So I'm going to square root, but I need to show that I'm square rooting both sides. Now what happens when you take, just simple math lesson over here, you take the square root of something with a square, what happens is the square root cancels out that square. So that's why I'm just going to have velocity. So this 31, when I take the square root, it's the same thing. It's going to cancel out the squares, not the meters and the seconds, just the square. Same thing right there. I just cross it out. So how to reach this in your calculator, okay? So in your calculator, depending on what calculator you have, okay, I'm using a graphing calculator. Scientific calculator is the same thing. To reach this part, you're going to hit your second button, which is usually in the top left corner, and then you hit that square root button. So in your calculator, you'll see the square root pop up. So when I hit second and that square button, I see the square root, and I just plug in 31 and hit equals. So now my final answer, 2 sig figs, which don't ever worry about rounding or sig figs to the end. I started with 2 sig figs. I just got to end with 2 sig figs. So 5.6, and because I'm finding velocity, meters per second. And I'm boxing that because that is my answer. So remember, with velocity, we need velocity to be meters per second. Okay, I wanted to show you a sample one in your notes, but in class we're going to do several examples too. See you on the next one.